Hello there and welcome back to our channel. In the last episode, we talked about contractual concepts regarding the value chain and how they all come together. Today, we will talk about some techniques for oil and gas exploration. The easiest way to explore for oil and gas is through what is known as a SIP, which is a natural occurrence of oil and gas that has leaked to the surface. That's how the first commercial oil well was located and drilled in 1859. The site was chosen because it had a SIP, and a well was drilled to increase the flow of oil to the surface. At that time, people didn't understand how oil was formed, migrated through subsurface rocks, and accumulated in traps. And so, for the next 50 years, exploration wells were randomly drilled or located next to SIPs. However, oil that has seeped to the surface gets degraded by one or more of three processes. The first process by which it gets degraded is called water washing. Water flowing by the oil well washes it and dissolves the lighter soluble fractions of the oil. The other process is called evaporation. Heating from the sun will cause evaporation of the lighter fractions, again of the oil. And the third process is bacteria. Bacteria on the surface will consume the lighter fractions. The total effect of these processes is an increase in the relative percentage of heavier fractions of oil, which are undesirable. Over time, the following other techniques for oil exploration evolved. One is geological techniques, second is geochemical techniques, and third is geophysical techniques. The first technique, geological, is simply based on scientific knowledge of rocks to determine where oil and gas might be residing underground. In the early 1900s, when the principle of oil accumulated in high areas of reservoir rock formations, such as domes and anticlines, oil companies started to hire geologists to map surface sedimentary rock layers. The mapping became more efficient with the development of airplanes and aerial photography. And in the 1970s, satellites orbiting the Earth came into use, taking photographs in infrared, visible, and ultraviolet light, and transmitting them back to Earth. The images, which can be enhanced digitally by computers, are made available to anyone who is interested at a uniform price. Satellites such as Landsat, American, which is American, Spot, which is French, and RadarSat, which is Canadian, have been used for this purpose. Using these images, geological reasoning can be applied to find oil and gas. The second technique, the geochemical technique, seeks traces of hydrocarbon in soil and water by taking and analyzing samples from seeps on the surface. Seeps are also common on the ocean floor and can be detected with water sampling equipment and some products they call sniffers. Using gas chromatographs, such traces of hydrocarbons in soil and water are usually good indicators of the proximity of a petroleum trap. The third technique, which is geophysical, is simply the application of physics and mathematics to the study of the Earth. It involves using gravity, magnetic, and seismic methods to explore the subsurface. Of these three methods, the greatest advances have been made in seismic methods, which involves sending sound energy down through the subsurface rocks, reflected off rock layers, and returned to the surface to be recorded. On land, the most common seismic methods are explosives and vibrator trucks, called vibrosis. At sea, an air gun mounted behind a ship is used to generate high pressure air bubbles in water. The reflected sound waves are captured by acoustic receivers, which are geophones on land and hydrophones on water, usually strung in arrays. They are wired to a seismograph, which plots the electric impulses received from the acoustic receivers, and either prints on paper or stores in a computer storage medium for interpretation by seismic interpreters. A large spectrum of colors is used to identify trends in the subsurface. Seismologists know what to look for in the seismic records generated by these devices as they pursue the primary purpose of determining the structure of the subsurface rocks. Digital recording of field data and computer processing have greatly improved the accuracy and value of seismic exploration. We hope you've enjoyed listening and that it's been simple, it made sense, and hopefully leads to success. Do not forget to hit the subscribe button, like, and share. We are Fossil TMB Services. Thank you.